So today we are going to take a look at securing our network in a very small office with a limited number of users. The whole idea is we have 4 or 5 clients, we have a simple switch, we have some users connected through maybe Wi-Fi or maybe through LAN cable. But the idea is to make sure the users who are legit get IP address from the firewall. This is called MAC whitelisting or DHCP MAC whitelisting. By default, when you create a DHCP server on FortiGate, the default action is to give IP to every client that sends an offer, but we want to prevent this. We want to make sure only whitelisted clients can get an IP address and therefore connect to the network. Note, this is a way to secure your network, but this is not the best way to secure your network because we all know MAC spoofing is very common and anybody can do MAC spoofing and then gain access to the network. But that's why I call it only usable for small office network with limited users. There are a lot better ways to secure your network, like network access control or I don't know, other stuff. There's millions and tons of ways to secure the network, but this is only applicable and useful for a small office. So stay with me to the end of this show. All right, let me tell you what happens in the background. We all know DORA. Do you? DORA. What is this DORA? When a client wants to join a network, it will always have to follow this step. The first one is discover, which a client sends an ARP packet to discover a possible DHCP server nearby. The next one is offer, where the DHCP server sends an offer to the client. And the next one is request. The client checks if that IP address is usable, because there is another step where the client sends a reverse op to make sure there is no conflict and so on. But the client, after doing some tests, requests the IP address from the DHCP server. And the last step is acknowledgement by the DHCP server, which DHCP server makes sure the IP is reserved for that client and does not release it to another client. So that's the whole step happens at the background. So imagine the left side is client or user end and the right side is DHCP server, or in our case is firewall. And these two vertical lines are times. And when a client tries to join the network, it sends a discovery message to find the possible DHCP server, and in our case our firewall. What happens, the next step is offer. So if we enable this feature on the FortiGate, it has a table of legit MAC addresses. The FortiGate will go through this MAC list to make sure the client that wants to join the network is legit. If the MAC address exists in this list, it will send an offer. Otherwise, it will not send an offer, and we can see it in the logs of the FortiGate. And the rest of the procedure will follow. So let's go and see how we can enable this function on FortiGate. For our test, we have two clients connected to the FortiGate. One is Linux Ubuntu server, and the other one is a normal CLI based Linux client. So if I send any request to find the DHCP server, it cannot find any DHCP. Why? So let me take you through the configuration. If you go to FortiGate to interfaces, in this case, this interface, this virtual switch, VLAN switch, is connected to both our Linux clients, right? So I configured already IP address and a DHCP server on it. But to enable MAC whitelisting, if you have to go to advanced, and then on IP address assignment rule, you have to right click and set action to block. by default, this action is set to assign IP. That means any user, any client joins the network and sends a discovery message, the firewall will offer a new IP for it. But if we block it, it will not assign any IP to the clients. So I have the MAC of my Ubuntu client here. So I'm gonna go and check the MAC address. I think this is the MAC address. Yeah. So if I whitelist this MAC, it should get an IP. Let's see. All right, assign IP. That's it. So just to make sure, I want to see IPA. There is nothing here, and if I click on wired, I can see there is still nothing here happening. So no IP, right? Let me enable this one. So sorry, if I enable, yeah, now it's connected. That means I already have got an IP, and this is the IP that I received from the FortiGate. So let's see in the logs. What do we see in logs? If we go to system event logs, we should see some information about the clients trying to join the network and if they are legit or not. And if I try this one, IPA, because I did not whitelist the second client, see there is no any offer received from the server. All right, in general system events, if I put it at memory, all right, here is our log, and if I just filter it based on having the DHCP word, so we can see DHCP client is blocked by the server. This is our second client. This is this one that cannot get any IP address, but the other one, see there is a DHCP ACK, which means our Ubuntu client got an IP address from our firewall. Now the bonus point. The bonus point is you can save the MAC address of that client in your address list. Just choose a type as your MAC address and save it here, and you can allow internet access based on the MAC address of the client. So this is what I have done here. I have created a rule. In this rule, I said incoming interface is the interface connected to the Ubuntu client and outgoing to the internet, and the source should be the MAC address of the Ubuntu destination, all typical NAT configuration, and so on. So I must have internet access on my Ubuntu. Let's see. Yes, I do have internet access. So that's all. I have to tell again, this is not the best way to secure your network, and be aware that some devices use MAC randomization, like latest Android devices. They usually use MAC randomization. So this might not be the best and reliable way to whitelist access to the network, but this comes handy when you have some PCs. They are always fixed, connected to the network, and you want to make sure no one else can just connect to your network and gain access to internet or other resources. That's it. Thank you so much. Have a good day. Bye bye.